Yeah. Today is January 9th, here at least in the US. Here it's like 9:35. Um, and I believe today is the eighth day in Future of Tanzania. So yeah, just making sure, can everybody hear me well before I get started? Before we get started, is everybody able to hear me well? Um, okay, I'll just assume that everyone can hear me. Um, so we'll just get started. Actually, we'll go straight to me for the first thing. Okay. So the first thing we're going to do is we're last time we went over like the loop exercises one, and we weren't able to go through every single one of them because like time constraints and stuff. So we're going to be going through some of the stuff that we weren't able to get through last time today. So let me share my screen. Oh, hold on. Sorry, one second. Um, uh, give me 1 second. Something's going wrong. Um, okay. Sorry about that. Um, yeah, I'll share my screen now. Um, okay. Sorry about that. Okay. So specifically today, I'm going to be going over questions 13, 15, and 16 because we kind of did skip those a little when we were going over the answers for these. So yeah, we'll just do those. So okay, number example 13. We want a Python program to get the Fibonacci series between 0 to 50. So basically, we just want all of the Fibonacci numbers. But like once we get a number that's over 50, we want to stop printing, or we want to stop printing before that number before that. So I mean, if you guys don't know what the Fibonacci series is, it's basically just like you start with 1 and 1, and then each term that comes after is basically just the sum of the two numbers before it. So yeah, okay. So for this one, what we're going to start by doing is we're going to give our upper bound. So we're going to have a number that's equal to 50. Because, of course, 50 is our upper bound. We don't want to go over 50. We want to make sure that stays under 50. And then we'll give our initial values, which, I mean, I know I said the initial values are 1 and 1, but it can also be 0 and 1. So what we're going to do, we're going to make first value equal to 0, and then we'll make our second value equal to 1. So now we have three things. We have our upper bound, we have our first and second numbers in our Fibonacci sequence. So for I in range of 0 to num, we're going to repeat some stuff because we're basically just repeating the same thing over and over again until we get to a number that's over 50. So for I in range from 0 to num, we're going to first check if the number, if I is less than or equal to 1. Sorry, I is less than or equal to 1. And the reason why we're checking if it's less than or equal to 1 is because um, the way that the way that we're doing this, we just want to move to the next number, basically on our first two iterations, because that's going to be these two values. So we're just going to make a new variable called x next and then make it equal to n, or sorry, not ni, because our first value is 0, we're making next equal to 0, and then we're doing 1, and then so on. And then after that, we're going to check if the number is within the range. So um, sorry. Um, see if uh, or actually, sorry, no, we're going to go to an else statement, I think, because basically we just want to do the same thing for every other situation that we have. And basically, we just want to keep adding um, our previous two values over and over again until we get to a number that is less than 50, or sorry, that is over 50. Um, okay, sorry, this is not an else statement. This is going to be another if statement. Sorry. Um, and in this if statement, we're basically going to have a certain way of breaking once the number is um, is more than 50, because we just want to break out of this whole for loop. So um, we're going to check if next is less or is greater than 50, then we break. And then else, we're just going to print next. Yeah. So, or sorry, what's wrong here? That's weird. It should not be doing that. Oh. Um. Okay. Sorry. I've seen the problem here. The problem that we're having is because we're not actually adding it. Sorry, that's my bad. Um, what we want to do here is instead have an else statement that just adds the previous value of I. So of course we have our first, like the 0, and then we have our 1, and then by that point we're making next equal to 1. But then after that we want to add the value before. So um, sorry, we're going to um, not there. Sorry, 1 second. I don't know why this is not. It should be working. Mm, oh, sorry. We have to have our next on the outside first, because if you remember your scope, um, this next inside of here is in this if statement, so it doesn't work for here. Um, this might be a bit better. Never mind. Um, I seriously don't know. Oh, I think we need to actually have a temporary variable somewhere. Um, sorry, I think I think I'm doing something wrong. Sorry, I don't know what I'm doing wrong exactly. Um, okay, there you go. Yeah. So basically, we're basically having two variables. Sorry, not one. Next and temp, where we're basically having our we're basically having our first one just be equal to next. Like for our first two values, 0 and 1, we're having next and then temp. So by the time we get to here, we're having both of these be equal to 1. So once we have temp 2, we're making that equal to our original value of next, and then we add next by temp, our next value, and that's what we're going to end up printing. And then we put this value to our previous what our value of next was before. Um, and then this makes it so that we're basically changing, basically adding temp to next, and then we're putting the original value of next into our new temp, which gives this. Sorry about the issue. I completely blanked on this portion. Um, yeah. Um, okay. I will move on from this, and then we'll go to okay. So next one we'll go over number 15 because that's the next one that we had to go over since we stopped on 14. Um, so yeah. So 15, what we want to do is we want to create a Python program that accepts a string and calculates the number of digits and letters. So we're going to basically be given a string that has a bunch of digits, a bunch of letters, like numbers and letters, and then basically want to count the number of each. So let's take this away. And for this one, we're going to do we're going to start with two things. Well, first of all, actually, we need to take in a string in the first place. So we're going to have a user input. So I'll just put like I guess just user input, and then we'll make that equal to um, input, and then we'll just put in like enter a string. Um, Afterwards, we're going to have two counters. We're going to have a counter for digits to count the number of digits in our string, and then we're going to need letters to count the number of letters in our string. So now what we're going to do is we're going to iterate through the string, and basically check if it's a number or a letter, and then we're going to print out the number. We're going to print them out later. So for I in user input, we're basically going to be having an if statement, which checks if that character is a digit. And there's actually a specific function we can do for this. We can do if I dot is digit, or sorry, not I guess that. Um, if I dot is digit, then we're going to increase digit by one. Or sorry, digits. And then in another case where um, it's a letter, we're going to be using what we call is alpha. And is alpha basically refers to, I guess you can think of it kind of like is alphabet. I need the parentheses. So that's what is alpha is. It basically checks if it's a letter. So if it's a letter, we're going to add one to letters. And then we're going to print the number of digits and then the number of letters by using the however many the count is. So print, I guess we could write a bit of like string for this. So like there are digits, digits, and letters, letters. So if we run this now, um, sorry, we're going to have to make these strings because right now they're considered integers and you can't add integers and strings. So that should be fine. So let's enter a string. Actually, we'll trash this first. Okay. We'll enter a string. Let's put in a random set of like letters and digits. So A, B, C, 1, 2, 3. So there are 3 digits and 3 letters. And we can run it again. We can say A, B, C, D, E, F, G. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. There are 10 digits and 7 letters, which is, there's 7 letters here, and there's 10 digits here. So yeah, this is going to be your code for, or something that resembles your code for example 15. Okay. And then we'll move on to example 16. So now we want to write a Python program that's going to convert the month name to a number of days. So basically, if we have like given like a month, we want to say the number of days that are in the month. So like for example, or okay, more specifically, we want to go through each of the months. So like January, February, wait, yeah. So like we just want to print out whatever is given. So okay, we're going to start with okay, I feel like I was a little unclear about it. It had bit of basically we're going through each of the months and um giving the number of days in each. We're not actually having any like user input where you give a day or give a month and it gives days. We're more making it so that it goes through each of the months. So it's going to say like January has some like 31 days, and then February has like 28 days. Um, but of course, like with a kind of like loop with it. Oh, sorry, I need these to be strings. How do you spell January? It was, I think it was just this January. So it was like February. Wait, February. Let's go through like let's skip one. April, June, September. That should be enough for now. Um, okay. So now I want to iterate through this list and basically just if if it if the um if the specific month is one of the months that we specified, then it's going to basically just give us something is like has a certain amount of days. So um, first we're going to have a for I in month. And we're just gonna have a bunch of if statements to check for each possibility. So if I is equal to um, February, Feb, February, then we're going to print the month of February as 28 or 29 days because they can also be leap years. So we're just going to say it has either 28 or 29 days. Um, and then um, we're going to have another situation for days with months with 31 days and then months with 30 days. So elif um, I is in, like we can just send a list through. So like let's go with the ones with 31 days first. So January, and then March, and then May. I forgot a space there. May, July, and then August, October, and then December. So these are all the months that are in that have 31 days. So in this case, we're going to print I has 31 days. And then we're going to have another situation, if where we're going to check for 30 days. So if I is in, and we'll have another list with April, June, I think September, November, and I think that's it. So in this case, we want to print. Yeah, we want to print I has 30 days. And then, of course, we just want to check that there's no cases where we have like a fake month name. So if it's not any of those, then we'll just print that is not a valid month name. Um, and yeah, that should basically do it. So if we, oh, sorry, oh, forgot to put spaces here. That should work better. Okay. Yeah, January has 31 days. Month of February has 28 or 29 days. April has 30 days. June has 30 days. September has 30 days. If we change this around, say like October here, we can put December here. We can put August here. Let's change this to like July. We run it again. You'll see that it gives us what we want. And then if we were to throw in some fake names, so we can just put in like um, gold, you'll see that it says it's not a valid month name. So yeah, this is the code for number 16. Okay. And I believe that is all of the stuff in the loop exercises, at least for loop exercises 1. So I am going to pass it off to Benjamin to do loop exercises 2.
Right. Hope my voice is clear enough. Right. So we're going to be going over. I don't think this was homework at all. So we're going to be going over this together, and I will be hopefully getting answers from the Q&A from playground or Q&A section. So this is loop exercise 2 from a different website called pinative.com, and yeah, we'll explain. I'll explain, and then we'll go through the questions together. Right. First, starting with what is the output of the following loop? So we have a segment of code here, and I'd like you guys to, without writing the code on your own devices, just by looking at the code and reading through them, what the answer would be between JHN and JHON. Uh, you guys can go ahead and answer in the Q&A chat. So if they run this segment of code, what will be the results? But trick questions. Any answers? Random guesses are fine. I got this wrong myself the first time I was solving it because if you okay, we got our first answer JHON, JHON. So it seems like people are agreeing that it's going to be JHON. So if we copy this over ourselves and run the code, we will get JHON. I don't know. So the reason here is pass is not the same thing as continue. So pass basically stops an if statement or for or while statements from erroring or like crashing your program when they have nothing inside them. So if I made a random if, let's say name equals, if I were to create something name equals my name, then name equals Ben. If I don't have pass here, this program will error. But if I have pass, it will not error. So the difference between pass and continue is pass stops it from crashing your program. Continue goes through that iteration. So if I change this to continue, this will actually give you J, I believe it was JHN. Yep. So that's the difference between continue and pass. Remember, pass just stops it from erroring, doesn't do much else. Continue actually skips through that particular iteration or whatever you're iterating through. It could be a list, it could be a string like what we see here. It could also be within a range command. This lets you continue over and skip over the rest of that iteration. So the correct answer is JHON. Second, if -3, will this be true or will this be false? So just plainly if -3. Would so basically will the code under if -3 run or will it not? So if -3 as a bool. It looks something like this. So the true false is will hello print or not print? If -3, is this true or false? If it's true, this will run. If it's false, hello will not print. Which one would it be? Any guesses? Any answers? 50-50. You can give it a good guess too. One thing I can tell you that is that this is not an error statement. So we got a false. We got two falses. Any other guesses? Any trues or all false? All right. So if we run this part of the code, it is actually true, meaning it actually prints hello. So the reasoning behind this is any value that's not 0 or empty in some cases. So for integers, it's 0. For float, it's 0.0. For integers, you have to have a completely empty string. No, for strings, you have to have a completely empty string. Those count as falses. So anything that's not a complete 0 or empty is considered true. So because -3, although it's below 0, doesn't matter. Because it's not 0, it is true. Therefore, the hello statement runs just fine. So the answer would this to be true. So this -3 could be anything from -3, could be 5, could be 100, could be -1,000,000. It will still be it will still evaluate to true. All right, next one, number 3. What is the output of the following range function? So if this seems confusing to you, what this is saying is literally what is it iterating through? What is the value of num every time it iterates through? Instead of this, you can think of it like just like this. This will ideally do almost the same thing. I'll explain what the end does a bit later. I'll explain what the end here does a bit later. So any guesses for this one? What will it print out to the console? So you guys can just give me you guys don't I'd rather have you guys type out the whole thing, so it'd be like, 2. Is it like 3, 4, 5, or is it actually going backwards? 2, 1, 0, -1. And if it's going positive or negative, where does it stop? So we got 2 going increments of -1, stopping at -4. We got 2 answers like that. We got 3 answers like that. All right, chime in. Yep. So we got 4 of the exact same answers. You guys are all correct. This will be the result. So to explain this, range depending on how many integers you feed it has a different function. So if you only have one integer, it goes from 0 to that particular integer. So in this case, it would be, if you run this, it would be 0, 1. If you add a second number, it starts at the first number and then ends before the last number. I think you guys got this pretty correctly from seeing the answers. 5 is not included. It goes from 2 to 4. Remember, this is exclusive, not included. Not included. And then 2 to 5. And then if we add a last integer, this tells you what increments you're going to be incrementing stuff by. So this is a -5 in this question. So it'll be, so if we put -1 here, it means we're going down by -1. If we put -2 here, we can also still make it work. And it will just print out a totally different number. It would be 2 goes down by 2, so 0, goes down by 2 again, -2, and then goes down again, giving you -4. So this last is how it iterates through that particular range. And as for this end command, I don't think you guys have learned this. So normally, if you see above here, it's made a enter, or it shows a different line every time you print it, and lets you not do that. So we set up basically a custom ending for the print. That's what the end is doing. The custom ending is comma and a space. We can see there's a comma and a space, comma and a space, comma and a space, and even to the last one, comma and a space. That's what the end command does. Not really important for today, but that's what it does. Number 4. I cannot show the question fully. Okay. What is the value of var variable after the for loop completes its execution? So what does it print in the end? What will it, so because there's a print command, what will it print out to the console after the code has been run? Very interesting question. Number 4. Also a bit of a trick question, so it may not seem like what it is. Remember the difference between pass and continue that I told you guys before on the first question? And solve away. Is it 20? Is it 21? Is it 10? Or is it 30? We got 30, 30. Any different answers, or is it all going to be 30? A very tricky question. It seems like we're going to get these two answers of 30 and 30. Let's see how it runs in an actual code. So before we run it, a couple of things to explain. The reason why it's made it into this less clear version is because if you do continue, everything below the continue code will not run. It will just skip to the next iteration. So that's why, because continue is already here, if this if statement is true, then it will hit continue. Oh, it's continue now. I'm just gonna skip everything below it, go back to the next iteration. So this will never run. And if you run the code, it will give you 21. So to explain why we get 21, I already explained how. So let's actually go number by number. First, I starts at 0. I doesn't mean much here. It just means there's going to be 10 iterations, but still. And then j in range 2, 10, 1. Like I explained before, the first number is the starting number. 10, the second number, 10, is the ending number, but exclusive. So 10 is not included. 1 is the iteration. So theoretically, we can get rid of 1, and it will do the exact same thing. I don't know why it's even there. But as for this command, if variable %2 equals 0, continue. So var right now is 10 because it's never has been changed before. If it's 10, it is when 10 modulus 2 or 10 divided the remainder of 10 divided by 2 is 0. So this if statement is true, and therefore it will continue, skip over this one, and then go to the next one, which is j is now 3. But because var never changed, but no matter what j is, j can be 3, 4, 5, 6, 7, 8, 9, which is when it ends. It will never change. It will still be 0, and it will still hit continue. It will hit var plus. It will never hit var plus equals 1. So through the first iteration, var is still 10. Then finally, at the end of this one, it changes to 11. Then now I is 1. So this is a second iteration. If you look at the second iteration, I is now 2. Now let's check this one out again. Remember, var is now 11. 11 modulus 2 is going to be 1. Remember, modulus 2 is basically straining out even and odd numbers. If modulus 2 is 0, it's an odd number. If modulus 2 is 1, it's an odd number. Yeah, if it's 1, it's odd. If it's 0, it's an even number. So because then this is just false, so this won't even happen. And it will iterate through again and again because this one's outside this one. It's inside the first for loop, but outside the second for loop. So it will just keep on running. The var will still be 11, and it will vary through all of it. And then now var will be 12 after finishing this iteration of for loops. But we already know by looking at 10 that because 12 is also an even number, because continue is here, it's never going to get added. So if we shorten it again, we can look into for I in range 10 just becomes do var plus equals 1 10 times, so it becomes 20. And then because the for loop ended naturally, remember, the for loop ended naturally, the else command runs. This comes in important later. The else command will run, and then var plus equals 1 happens once more, making it 10, and then we did this one 10 times, so it's now 20, and then we did this one more, making it 21, and 21 is the correct answer. Next, I really wish the ads weren't here. Given the nested if-else structure below, what will be the value of x after code of, oh yeah, the answer was 21, like I said. Execution completes. So what is x? after the code is run. It's actually really simple, this one. Really, really simple. Really, really simple. Just how? What would X be if we iterate through this one? Got 2. Because we're running a bit short on time, I think I'll just go with one answer for now. So 2. Is it 2? Let's look at, oh, we got 2 2s. So if you look at the code here, X is 0, A is 0, B is -5. We hit if A is bigger than 0, which it is not. So everything under here, useless. Won't run. You do not need to care about it because this is false. Then we hit the else command because that was false, and then x equals x plus 2. X is 0 still. So 0 plus 0 plus 0 equal x equals 0 plus 2, meaning x is now 2. Run it. Here we go. X is 2. Number 6. What is the value of x after following nested for loop completes execution? So the answer for this one was 2. What is the value of x after following nested for loop completes its execution? So ignore this print x because this is inside a for loop. What will x be at the end of the code? End of the code. So it would look something like, what is x? Or just the print x. What is printed here? Ignore this. What is printed here? What is the variable x, the value of the variable x at the end of the code? Any ideas? Any answers? The answer options were 99, 90, and 100. We got 90. All right. Anyone else? Another 90. Any other number than 90? 100 or 99? If no other answers, then oh, we got another 90. All right, let's see it. So we'll have to look at the last number. It is 90. So the mathematical, I guess, the mathematical ish thing behind 90 is, so how the code is run. I in range 10. So whatever is inside I will run 10 times. You guys can think of it as that. For j in range -1 to -10 at -1 intervals. What this means is basically uh starting at -1, it will go down to -10. at -1 intervals. So we'll basically go -1, -2, -3, -4, -5, all the way to -9, because it's exclusive, remember, all the way to -9. So meaning everything inside here will run 9 times in total, 9 times. So starting at 0, we get 1, because this code is ran 9 times, we add 1 9 times, making it 9. So we can see here, it just, well, this just adds it, so it's pretty useless. But and then range 10, because it's that addition of 9 times is run 10 times again. So it basically becomes 9 plus 9 plus 9, do that 10 times. So basically it's 10 multiplied by 9. 10 multiplied by 9. So we get a 90, which is our answer down here. I think the question should have done like this and give us a clean answer. I think this question might have been a typo, like wrong indentation. That's why indentation is very much important, guys. So it is 90 for number 6. Number 7, what is the output of this if statement? What is the output of the question code would be a better phrase, not if statement. So if we run the code, what is the output? What do we get on the console? It's also true. 50-50 answers again. But true, true. I'll wait for one more answer. True. All right, 3 truths. Is it true or is it false? The answer is true. So this first statement basically sets A to 12 and B to 5. This is how you do, this is a very unique feature of Python. Other languages don't have this usually. So very useful feature. A is 12, B is 5. And then if we see here, it's 12 plus 5 is 17. Remember, if it's not 0, it's always true. So because 17 is obviously not 0, it is true. So print true runs and else statement is ignored. If we run it, we will get true. And true is the answer. Next, a bit of a long boy question. What is the output of the following nested loop? We got 2 lists, numbers, and items. So instead of writing this down, you can tell me if it's number 1 or number 2. If it takes a bit too long to write. So number 1 or number 2, what is printed out using this print statement? And this print statement is actually on the correct spot this time instead of being on the wrong spot like it was last time. So you guys can just happily look at it. What is the result of the following nested loop? Number 1 or number 2? These 2 are the only choices. There's no more choices in the question. So another 50-50 chance. We got a 2. All right. 10 chairs, 10 tables. That another 2. All right. So this is the answer to this one. I will also explain. So we have numbers and items, and we're iterating through both of them here to x and y. So first, because we're doing numbers first, we get 10. So 10 is x in the first iteration. Then we go into the second iteration, y in items. So y is first chairs and the next tables. Remember, x is still 10. So it does print 10 and chair. And then It still has to iterate through items again. It has not finished. It only has done chairs so far. Now it has to do tables. So it does 10, it does another 10 tables. And then the iterations finally finish. For x in numbers, now x is 20. And then it iterates through this again. So it's 20 chairs first, and then next is 20 tables. It was number 1. So, like I said, first of all, first x is 10. So, and then it iterated through chair and table. So it became so print 10 chair and 10 table. And then and later it became 20, iterated through again, did both chair and table. So the answer was number 1. Number 9, what is the output of the following for loop and range function? Basically identical questions to what we did last time. How do we use for loops and range command? Range command, remember, more variables means different things, actually. You guys can give me the whole number string. You guys can give me the number of your choice. Negative 2, 3, 4, negative 2, negative 3, negative 4, negative 2, negative 1, negative 3, negative 4. One. All right, so we have multiple different answers here. This is quite interesting. Let's see it. So I'll do this time I'll just show you guys the answers first. It is negative 2, negative 3, negative 4. Like I said, the first, if there's 1 in range, if there's one integer in range, it goes from 0 to that number exclusive. If there's 2, it goes from the first to the second one, also exclusive on the second one. And if you have a third variable, which we do here, it tells you the interval. So instead of usually going +1 intervals, which is what its default set to be at, we're going -1. So we're going backwards, -2, -3, -4, until we hit -5, which is exclusive, so we stop at -4. That's why we get -2, -3, -4, and then I explained what n does. Instead of usually when print do you get an enter, you can set it to be a custom one. This is what it's doing. So the answer is number 4. Number 10, just 3 more questions go. 13 questions, I believe. Yeah. What is the value of x? What does this print to the console? Any answers for this particular one? We got 2 infinity and then 100. So infinity means this while loop will not end. That's what it means. So the answer is, we'll see. I'll show you guys the answers for this one first as well. It is 100. So if we look at what it's doing is, first let's just run through the code. X is 0. X is smaller than 100. X is now plus equals 2, meaning added x added by 2 is now x is 2, which is, and then it erased through it again. 2 is still smaller than 100, so it becomes 2, 4, 6, 8, continued. And then it hits 96 eventually, 96, and then 98. 98 is still smaller than 100. So this one runs. 98 plus equals 2 is 100. Then now it's not smaller than 100, so it stops. While loop is end. Not infinite, it ends there. And then we print x, which is 100. There we go. Next, number 11. If else below. Shit, doesn't fit. What will be the value of x when the code is executed successfully? So what does x print again? What is the result of this code? What is x? A little bit more complicated than last time, but shouldn't be too hard. Remember, when looking at if statements or for that, or for loops or any loops for that matter, look at it from the outside in the beginning. You might be able to skip a lot of stuff if you know what you're looking for. We got 3. Any other answers? We got another 3. Another 3. All right, so we got 3 threes. Let's see it. So this time I'll run through the code first before giving you guys the answer. We got 100. Interesting. All right. So x is 0. So x is 0, a is 5, b is also 5. Is a bigger than 0? Yes, it is. So it is now in this if statement. And this else is cancelled. It will never run because if was true. This if was true. Is b smaller than 0? B is 5. No, it's not. Skip over. Else if uh is b is a bigger than 5? No, it's not. A is 5. It's not bigger than 5. It's just 5. It's equals, but not bigger. So this also skipped over. Now we hit else. Because these both of them are false, we're on else. X equals x plus 3, meaning x is now 3. And because like we said, because this if statement was true, the original one, this else is skipped over. Therefore, we get print x is 3. Not 100, but 3. Yes, there we go. It is 3. Number 12, what is the output of the following nested loop? What is the output? You guys can give me 1 or 2. I actually got tricked by this question myself. Number 12. The key thing here will be the VC a break command. Maybe that will come in handy. What does it do? What will it do? We got 1113, so that would be number 2. Another 1113. It's a very slightly confusing questions just because of the number of variables involved. Another 2. All right. So the answer, universal answer seems to be going with 2. Let's see if you guys are right. So first, let's run the code to see the answers. It is 1, 10, 11, 12, 13. Why is it that? So here's slightly confusing and quite a bit interesting part. For a num in range 10 to 14, this means num is going to be 10, 11, 12, 13. Remember, it's not 14 is not included. So let's look at when num is 10, the first iteration. For I in range 2 to num, meaning starting from 2, it goes all the way till num, which in this case is 10. So it goes from 2 to 9 because 10 is exclusive again. If num percent I, meaning num modulus I, remember, so num is 10. I is at first 2. Is it equal to 1? No, it's not. So it skips over this. Now I is 3 because we're iterating to 2 to 10 here. Is now 3. And num is still 10. 10 mod 3. 10 divided by 3. The remainder of which is 1. So this is true. So we print num, which is 10. And then we break, meaning it breaks this for loop. It doesn't break the original one. No. But it brings this one because that's what it's referring to when it says break. Now it's 11. Uh, this is the slower way of solving it. There's actually a faster way to do it. So I'll explain the faster way a bit after. So 11, if we look at it, 11 range to, same thing. Num is now 11. It goes from 2 to 10. I is first 2. 11 mod 2 is already 1. So print num, which is 11, which is 11 currently. Remember, 11 modulus 2, 11 divided by 2, the remainder is 1. So this is true. So we get print num, and then we break it again. So this thing's broken now, again. Now num is 12. We're almost there. 2 to 12. So now it's from 2 to 11. First I is 2. 12 modulus 2 is 0, because 12 divided by 2 has no remainder. Next, it's 3. I is now 3. 12 divided by 3 also has no remainder. It's 4. No remainders. I is now 4. 12 divided by 4, still no remainder. It's 3. Well, and then I is now 5. 12 divided by 5 has a remainder of 2, not 1. So still not 1. Then we get to 6. 12 divided by 6, no remainder. 12 divided by 6 is 2. 7, we get a remainder of 5. 8, we get a remainder of 4. 9, we get a remainder of 3. 10, we get a remainder of 2. And when we hit 11, which is the last iteration, because remember it's exclusive, it does not include 12. When we hit 11, 12 modulus 11, 12 divided by 11 has no result, and then the remainder is 1. So print 12, and then break it again. It doesn't need a break because it's the last iteration, but anyways. And then 13. 13 here, 1, 13 here, 2 to 12 basically. And then I starts out with 2 again. So 13 divided by 13 modulus 2. 13 is an odd number. Remember, modulus 2 gives you if it's odd or even. Odd number, 1, print 13. So we get 10, 11, 12, 13. This is the slower way of solving it. The faster way of solving it, if you look at the question, it goes from 10, it goes from num to the number right below the number. So unless the num is 1, no, unless num is 1 or 2, 10 modulus 9 is 1. 11 modulus 10 is 1. 12 modulus 11 is 1. 13 modulus 12 is 1. Because the last num is always going to be here, this print is always going to work. And because there's a break statement after it, it can only run once too. So in theory, if you think of it from that perspective, it will always be there. 10, 12, no, 10, 9, 11, 10, 12, 11, and 13, 12. So it is, in fact, the first one. Lastly, multiple choice, or choose multiples, I guess. There's 4 sets of answers. 1, 2, 3, 4. Give me your answers. So Python's for loop used to iterate over the items of list, tuple, dictionary, set, or string. Else clause of for loop is executed when the loop is terminated naturally, or when it's terminated abruptly. Abruptly means it was using a break command. And then the fourth one is we use for loops when we want to perform a test indefinitely, meaning infinitely, until a particular condition is met. Remember, there might be more than one answer, so give me all of them. It could be 1, 2, it could be 1, 3, it could be 1, 2, 3, or it could be all of them, or it could be just one. Just one, or it could be just 2. It could be any of them. First choice. So we got number 1 here. Any multiple of choices? Last question, guys. Last question. All right, so I'll explain this briefly. So for loops are used to iterate things. Remember, for list, for string, for range, all of them iterates to a list or a set of sort. And then, so it is true. Else clause for loop is executed when loop terminated naturally. This is true. Remember from way above where we had a for else? Here we go. Else, for else. This only happens when it's terminated naturally, meaning it went through all the iterations. It is, however, not done when it's terminated abruptly, meaning it was either stopped by a break command or something else. Last one, force. We use for loops when we want to perform a task indefinitely. Do we? That's what while loops are for, not for loops. While loops goes indefinitely until the condition is met. For loops stop or stops when there's nothing to iterate through anymore. So 4 is false. The correct answer is 1 and 2. So if we submit the answers here, 13 out of 13 points total. If you scroll down, you can see it's number 1 and number 2. Sorry, Jess. It was number 1 and 2. All right, that'll be it for this particular section. Oh, you did say 1 and 2. All right. I will next pass it on to, I think, Baron for coding bets. Yeah, thank you guys.
Yeah, so I will be going over the logic one portion of coding bat. So please give me one moment and share my screen so you guys can open coding bat as well. Okay. Okay. I'll just give a moment for everyone to start watching. Okay. So for this exercise, basically it's called cigar party. And when squirrels get together for a party, they like to have cigars. And basically, a squirrel party is successful when the number of cigars is between 40 and 60, unless it is the weekend, in which case there is no upper bound for the number of cigars. Return true if the party with the given values is successful, false if otherwise. So what I want to do here is the first thing I want to do is I want to broaden the problem. So let's check whether it's a weekend or not first. So let's do if is weekend, right? So if it is a weekend, then that means that there's no upper bound on the amount of cigars that we can have. So obviously there's no upper limit, but there is an under limit. So it has to be at least 40. Okay. So if is weekend, we need to have at least 40 cigars. Now, instead of checking like, oh, is cigars greater than or equal to 40? If true, then like return true. Instead of doing that, we can just return a condition. So return then cigars is greater than or equal to 40. Okay. Else, right? So if it's not the weekend, then we essentially just need to check whether we're in the bound that we were given. Okay. So that would be lower limit, and it also meets the upper limit. Okay. So yeah, a score party is successful when the number of cigars is between 40 and 60 inclusive. Check. Unless it is the weekend, in which case there is no upper bound on the number of cigars. Check. Return true if the party with the given values is successful or false otherwise. Right? Um, so yeah. Also, I will zoom in just in case you guys can't see. Because I think someone said to zoom in my screen. So sorry about that. Um, but yes. So can everyone see my screen better? Okay. Then I'll keep it like this. So essentially, right? I'll just re-explain it in case you guys were not able to see it. Basically, this is checking we are currently in the weekend, right? And that's the sentence here. So how I like to tackle these coding problems is just think of it as you're translating English to Java, or sorry, English to Python. Okay. So we're translating this here, and then there is no upper bound on the number of cigars that's here. And then otherwise, right, we have to check if the number of cigars is between 40 and 60, which we do right here. Okay. So we can click go and um, so oh right. So I have to put this in parentheses. Right. Okay, that is to put sorry, got confused. But yeah, as you you guys can see, that is all correct. Yes, you write and in Java, and I was getting confused with Java. Anyways, yeah, we get it all correct. So on to the next question. You and your date are trying to get a table at a restaurant. The parameter U is the stylishness of your clothes in the range 0 to 10, and the date is the date's parameter is the stylishness of your date's clothes. The result, getting the table, is encoded as an int value with 0 equals no, 1 equals maybe, and 2 equals yes. If either of you is very stylish, 8 or more, the result is 2, which is yes. With the exception that if either of you has a style of 2 or less, then the result is no. Otherwise, the result is 1. So it literally gives you the formula to do this problem. So let's go up. Okay, so first let's start with the not being fashionable. So if you or your date both have a style of 2 or less, so if U is less than or equal to 2 and date is less than or equal to 2, right, then we're definitely not going to get a seat. So return 0. And then say maybe you're both very stylish. So you're both over 8. Then we're guaranteed to get a seat. So we return 2. Otherwise, we might get a seat. So we return 1. And then so now we're going to go ahead and debug. And so I accidentally put and here, but it is or. So it has to be either one of you. So it's notice how it says either of you is very stylish. So that means that it has to be an or, right? But yeah, very straightforward. So that is the date fashion problem. On to the next. These squirrels in Palo Alto spend most of the days playing. In particular, they play if the temperature is between 60 and 90. Unless it is summer, then the upper limit is 100 instead of 90. Given an int temperature and boolean is summer, return true if squirrels play and false otherwise. Let's do the same thing here. Let's go really broad. Let's check if it's summer first. Okay, so if is summer, then we're gonna play if it's between 60 and 60 and 100, right? Because it's summer. So we're gonna return temp is greater than or equal to 60 and temp is less than or equal to 100. Else, we're going to return temp is greater than or equal to 60. And instead of 100 here, we're going to do 90, right? Because it's not summer. And we get that all correct. It's super simple of a problem. Okay. You're driving a little too fast and a police officer stops you. Write code to compute the result as encoded as an int value. 0 equals no ticket, 1 equals small ticket, and 2 equals big ticket. If the speed is 60 or less, the result is 0. If the speed is between 61 and 80 inclusive, the result is 1. If the speed is 81 or more, result is 2, unless it's your birthday, and on that day, your speed can be 5 higher in all cases. Now, a big thing that I want to emphasize is that there's an easy way to do the birthday thing, right? Instead of doing like a if it is the birthday, like, and then do 3 different conditions, checking if it's like instead of 60 we check for 65, instead of 61 we check for 66, 80 we check for 85. Instead of doing that, all we can do is if it's our birthday, we just do speed minus equals 5. That's all we do. And then now we can check. So if our speed is greater than 80, we are most definitely getting a big ticket. And if the speed is between 61 and 80, right? So if it's like that, and it's remember it's inclusive, then we will return 1. And then otherwise, we're not getting a ticket. So we return 0. Okay, so that is caught speeding. Basically, we do the birthday first. If it's our birthday, we lower the speed by 5 so that when we check it, we don't have to do a big hassle. And then if the speed is more than 80, we get a big ticket. Between 61 and 80, we get a small ticket. Otherwise, we get no ticket. Super easy. Okay. Given two ints a and b, we are going to return their sum. However, sums in the range 10 through 19 inclusive are forbidden. So in that case, just return 20. So here, what we can do is we can just do sum equals a plus b. If sum is greater than or equal to 10 and sum is less than or equal to 19, we just return. And then we return our sum. Okay, and this works because basically we make a variable sum, right? And this sum is going to store the sum if we use it. And then now we are checking whether our sum is forbidden. Okay, so if it's forbidden, then we print 20. Otherwise, we're going to print out our sum. Okay. Alarm clock. Given the day of a week encoded as 0 equals Sunday, 1 equals Monday, and etc. Basically, we also have a Boolean indicating whether we're on vacation, and we have to return a string from the time of the form 7 o'clock, indicating when the alarm clock should ring. So it should just be normal hour and minute format. So on weekdays, the alarm should be 7, and on the weekend, it should be 10, unless we're on vacation. Then on the weekdays, it should be 10, and on weekends, it should be off. So the first thing we're going to do is we're going to check for vacation. If we're on vacation, or let's check for off vacation first. So if we're off vacation, and let's say it's a weekend. So if the day is equal to 0 or the day is equal to 6, right? This means it's Sunday or Saturday. Then we will return 10 o'clock, right? Because it's a weekday and we're on vacation. And then otherwise, we will simply return 7, right? Yes, that means that we are on. And then else, if we are on a weekend, then we return off, right? Because we're on vacation. And then otherwise, if we're not on a weekend, we are going to return 10 a.m. Okay. So yeah, pretty straightforward problem. Oh. Yeah. So yeah, that is the alarm clock problem. Okay. The number 6 is truly a great number. Given two int values a and b, return true if either one is 6, or if the sum or the difference is 6. Note that the function abs_num compares the absolute value of a number. So our conditions are if if either one is 6, so if a equals 6 or b equals 6, or their sum or difference is 6. So if a plus b is equal to 6, or, and then this is where it gets tricky, we don't have to do like a minus b equals 6 or b minus a equals 6. We can just do the absolute value of a minus b equals 6, because this is just going to get whatever sum get whatever difference it is, and then make it positive. Obviously, you guys have learned absolute value, and then it checks whether it's 6. Okay. And then if this is the case, we return true. Otherwise, we return false. Okay, and that is loves. Okay. Given a number n, return true if n is in the range 1 through 10 inclusive, and unless outside mode is true, in which case return true if the number is less or equal to 1 or greater or equal to 10. Okay, so let's check for outside mode first. Okay, so if we are in outside mode, and if our number is between and it's between 1 and 10, oh, sorry, apologies. So what I meant was, if we're on outside mode, we're checking if the number is outside of the range 1 through 10. Okay, so if it's either less than 1 or greater than 10, then we are going to return true. Otherwise, we return false. And then if it's not outside mode, we're searching for whether it's inside. So if n is greater than or equal to 1 and n is less than or equal to 10, we return true. Otherwise, we return false. And yeah, we get it all right. Okay. Given a non-negative number num, return true if num is within 2 of a multiple of 10. Note that a mod b is the remainder of a dividing by b. So 7 mod 5 is 2. And you guys can check out Introduction to Mod later if you guys would like to. So yeah, in order to solve this problem, essentially we're checking if we're 2 away from a multiple of 10. What we're gonna do is we're gonna check if mod if num mod 10 is less than or equal to 2. But if it's less than or equal to 2, or sorry, if it's less than 2, or I meant less than or equal to, because right, this includes 8, 9, 10, right? Or it's greater than or equal to 8, right? So this means we have like 0, 1, and 2. Okay, so if it's either one of these, right, then we return 2. Otherwise, we return false. Okay, and that is near 10. So that is it for logic 1. If you guys have any questions, feel free to leave them in the questions channel. Otherwise, that is all for logic 1, and I'm going to pass it off to Ian, who's going to go over logic 2.
Yeah, so I'll be going over logic 2. Let me just share my screen and we'll get started. So the first question is make bricks. So what this question is asking is we want to know to make a row of bricks that is there's a variable called goal and it needs to be like a certain inches long. And we have small bricks and big bricks, and the small bricks are 1 inch and the big bricks are 5 inches. And we have to return true if it is possible to make the goal by choosing from the given bricks. Okay, so the question says that we should try not to use any loops. So I'm gonna show you guys the solution of just using a return statement and trying to solve this problem. Okay, so these are just a couple of test cases, and I'm gonna start by saying return from here, and then to reach the goal, I need to make sure that if I add the small and the big bricks together, then it should be greater than or equal to the goal. So that's the first thing I'm gonna code out. So I'm gonna say small, and then it's 1 inch, so you can say times one, but technically times one doesn't do anything in this case, so I'm just gonna say small, and then plus big, and then since big is 5 inches, I'm gonna say multiply by 5, and then after that, um, I'm going to account for a second scenario where the goal, if the goal divided by the big brick, so 5 inches, then that needs to be equal to or smaller than the small bricks. So smaller than like how many inches it is after I divide the goal by 5. So I'm gonna say and then goal, and then I'm gonna say mod. Since the modulus operator takes into what I have after I divide. So I'm going to say mod 5 since the big brick is 5 inches long. And I'm going to say that has to be less than or equal to small. And oh, and I forgot to add the greater than or equal to goal here. And if I submit that, then all the test cases should be correct. Okay, so that's all for make bricks. Let's move on to the second one. Okay, so the next one is lonesome. So this question is asking, there are three integer variables, um, a, b, and c, and we need to return their sum. But if in the case that out of the three here, there's like a repeat, so like 3, 3, then we have to like ignore these two and just like print out 2 in this case. So I'm gonna use if statements to code this out. So I'm gonna first say um I'm gonna start by saying if all of the three numbers are the same, then I'm going to return 0. Since if all of them are the same, then I account for nothing, right? So I'm gonna say if A equals B and that also equals to C, then I'm going to return 0. So that's my first scenario. And I'm gonna say elif, and then I'm just gonna go in the order of like if A is equal to B, then I'm gonna return only C, things like that. Okay. So the first one is A equals to B, then I'm only gonna return C, um, just like that. And also elif if return A. Okay. And then else, and then the last scenario I have is just add everything in case um two variables are not equal to each other, okay? So I'm going to say return a plus b plus c, and then that should give us the correct answer. So yeah, all the test cases were passed. And next, um, question is lucky sum. Um, Also, this like similar to the last one, given three integer values, we need to return their sum as well. And the thing says if one of the value is 13, then we don't count that towards our sum. So I'm gonna just say if I'm gonna designate like a first to be 13. So let's say a is 13, right? So if a is equal to 13, then since everything on the right is not counted, I'm gonna say return 0. So um this is the a place, and then if this is 13, everything on the right should not be counted for. So that's gonna return 0. And then oops, and if that's not the case, and if b is 13, then so if this is 13, then only this would not be counted for, so I would only return a, since this is not on the right, it's on the left. So um it should say return a. And then um I'm gonna put 13 at c, so c equals to 13. Then since c is here, then that there's nothing on the right, so I can account for everything that's on the left. So I'm gonna say return a plus b. And if there's no 13 in any of the three values, that I'm gonna say return a plus b plus c. And then let's submit that, and everything should be correct. Okay. Next question is no teen sum. So this is asking so like the numbers that include like teen at the back, so like 13, like 18, things like that. So 13 to 19 are the numbers that have that. So given the three integer values, um if I see these numbers, then I'm gonna count it as 0, except 15 and 16. So the question says I need to write a separate helper, like, so I'm gonna just put that on the top here. So I'm gonna say def fix teen, and then I'll go with x. It can be any variable you want, but I just usually go with x for most of my codes. So I'll go with x here and x, and then I'm gonna put like a range in the if statement. So if 13, and then so 13 is also included, so I'm gonna say less than or equal to x, and then I'll just say less than or equal to 19. That way x is everything including 13 and 19 and everything that's in between. And you have to say except 15 and 16, right? So you're gonna say and um x does not include, so not is exclamation point, 15, and x does not include 16, just like that. And that's gonna return, like the problem says, 0. And then since I need to close out this, write a uh, separate helper, I'm gonna close it out by saying return x. Okay, and since we have the helper now, let's work on our main. um, so I'm gonna say return, and then this is the same as that I need to get the sum of a, b, and c. So by putting fix teen here, and then putting a, I'm checking if a meets any of these conditions, and if it does, then it's gonna return 0. Okay, so I'm just gonna do that for all of a, b, and c. So I'm gonna say fix teen a, and then fix teen b, and then add fix teen, and then c. So that way a, b, and c are all checked for these conditions, and it returns 0 if necessary. If not, then it will just get the sum of a, b, and c. So if I submit that, then all the test cases were passed, so we did do this correctly. Okay, next question is round sum. So for round sum, we have to basically just round everything to the next multiple of 10. So if it's 15, or sorry, 5 or more, Then 15 like rounds up to 20. Let's say like 18 also rounds up to 20. So just the next like multiple of 10, we have to round every number up to that. And then we need to get the sum of A, B, and C as usual. And if it's under 5, so if the most rightmost digit, so like the ones place over here, is less than 5, then we round down. Okay, so let's try to code that out real quick. So oh, one more thing. It like the previous problem, we also need a separate helper for this. So I'll just so we need a return statement here. So I'll leave that blank for now, and then let's work on the helper since we do need that right now to code out the main return statement. So just like the problem, I'm just gonna say round round 10 and then num um and actually I'll just say n here since it's just a variable and just to keep it simple and short. And I'm gonna say if so we need the multiple of 10, so we actually need the modulus operator here. And then we need to check if you divide that if you divide a number by 10, if that's equal to 5 or greater than 5. So the way I do that is n and then modulus 10, and then I need to check if it's greater than or equal to 5. And if it is, then I'm going to return n, and then we're going to divide that by 10, since we need the multiple again. And so divide that by 10, and then since if it is equal to or greater than 5, then we need to round up, so I'm going to say plus 1 here. And then since we divide that by 10, we actually need to make sure the place values are correct. So I'll multiply that by 10 here. And then if that's not the case, so if it's not greater than or equal to 5, then I'm just going to return. And then this is basically the same thing, except we don't have that plus 1. So just just like that. And now that we have the helper, let's complete this. So same way we did the previous problem, the helper is going to consider all of A, B, and C. So I'm going to say round 10A, and then plus round 10B, and then plus round 10C. That way A, B, and C are all accounted for, and let's submit that. Then all the test cases should be correct. Okay. Next problem is close far. So for close far, again, there are 3 integers, and you have to return true if one of B or C is close. And if it's far, so which is the values of 2 or more, then yeah, so that's the other value. And then we need to use the absolute value function as the problem mentions. So if I were to code that out, um, I'll start by getting the difference between B and C. Okay, so I'll say if, and remember, this is like basically finding the distance between B and C. You do need an absolute value function here in order to get the correct difference. So I'm going to say absolute value B minus C, and then the problem says both other values by 2 or more. So um, I'm going to actually reverse that and then mark that as false here. So I'm going to say if the absolute value of B minus C is less than 2, then this says true, but since I flipped this, then I'm going to say return false. Okay. And next, to close out this main thing here, I'm going to say return, and then I need to account for everything at this point. So um, I'm going to start by doing A minus B first. So absolute value of A minus B. Um, and if you look at this here, it says differing from A by at most 1. So at the way I mark at most is the A minus B has to be less than or equal to 1. So I'm going to say oh, less than or equal to 1. And then I'm going to do and So remember not or because we need both conditions here. So I did a minus b, and then now I'll do a minus c here. So absolute value of a minus c, and this one is the value of 2 or more. So I'm gonna do greater than or equal to 2, and I'll do or, and then I'm going to just flip these conditions around basically. So absolute value of a minus c, and then I'm just gonna write the same thing here, but I'm basically just flipping the conditions. So um, less than or equal to 1, and absolute value of a minus b is greater than or equal to 2, just like that. And this is gonna consider for any like not true values. So this if statement is meant to do that, and the return statement is to return for anything that is true. So if I submit that, all the conditions should be correct. Okay. Next problem is make chocolate. So for make chocolate, um, we have a package that has a certain goal of like a certain amount of kilos of chocolate. And we have, so just like the very first problem we went over, we have a small bar, which is 1 kilo, and a big bar, which is 5 kilos. And we need to return the number of small bars we need to use, and we have to use the big bars before we use the small bars, and we have to return -1 if not, like if this operation cannot be done. Okay, so first I'm gonna basically break this problem up into 3 parts. Okay, so first I'm gonna consider the part of -1, so whatever that cannot be done. So I'm gonna say if, and then since we have to do big bars first, I'm gonna write big, and then since big is 5 kilos, I'm gonna do multiplied by 5, and then add small. And then if this times 5, and then plus this is less than the goal here, then it returns -1. So based on this test case, I can figure out that um, if the big and the small are added together and that's less than goal, then I have to return -1. And okay, so that's the first part of my problem. The second part is I'm gonna do if goal. So if this goal over here is less than or equal to the big, so less than or equal to big times 5. So I'll do this one for example. So if this goal, and then if you multiply the big by 5, so this would be 1 times 5, so it's 5, right? So if that is less than, if the goal, sorry, if the goal is less than big, then that would be not, sorry. Um, let's see. Okay, let me just put this first, and then here I'll put an if statement inside first, and then I'll consider for like the condition that may not be true in this in this big if statement. Okay, so in this case, I'm basically doing the reverse of this, except I'm going to consider just small here. So I know that doesn't really make sense, but I'll try to explain it as we go along. So if goal, and then I'm going to actually do mod 5 to get the bigs. So mod 5, and then as you can see here, if so this test case is obviously a true test case, and the goal, if I do mod 5 on it, is going to be 4, right? And then the 4 is small in this case, so the small gets printed out. But if this is a false test case here, if I do mod 5 for that, that's 2, and that cannot be greater than 4, which is small. So that's going to be the false statement. So I'm going to do if goal mod 5 is greater than small, then that cannot be true. So that's going to be my first, like, um I guess exception in this big test case, and since I have the if exception, I guess, then I'll have to do else. So else, and I'll just put this back here. So return goal and then mod 5. So what that did was I considered for the exception here, and then I did an else statement, um and then whatever is it within this big thing, I did an else statement, and then if I did mod 5 of goal, then I would get the small. So this big part is basically considering for the smalls. And then so that's the second part of my solution. And the last part is I'm going to do else, and I need to consider for basically big now. So this is going to be basically similar to this, except I'm going to be subtracting out the big um from the goal first. So if goal minus big times 5, that's gonna be the goal subtracted, sorry, the big subtracted out from goal, and then that has to be greater than small in this case. Um, and that also needs to return -1 since this is a false test case. So if you guys want to try it out on your own, so try to calculate this um, according to the solution and see if it returns -1. You guys can try that. And if I do else, and then since this was like the exception of where you would get a false solution, you need to return another statement that will give you like the true condition. So if I do, since I subtracted out the goal from no the big from the goal, then I also need to return that out since that is considering for the rest of what I subtracted out. So what I mean by that is using this one as an example. So 7 is goal here, and then big is 5. And if I subtract that out, that would be 2. So that's the way I get 2. So that's the third part of the solution. If I submit that, then all the test cases should be good. I believe, yeah. So that's all for logic 2. If you guys have any questions for that, then you guys can leave it in the Q&A. And um, I believe we are out of time. I think we'll give you guys the homework first. Um, yeah, so I'll pass it off to.
Yeah, I'll be giving you guys the homework for today. Um, so today, oh, sorry, let me share my screen real quick. Um, so you're going to have to do the last two like areas inside of coding bat. You're going to need to do string 2 and list 2. It's not that many here, but these are going to be a little harder than the ones that you've encountered before. Just like I mean, yeah, there's less, but they're harder basically. So there's a coding bat, and then there's also some extra homework. It's going to be just some multiple choice problems. And I think there's like 40-ish for both. So yeah, those will be sent in a second. And yeah, so yeah, two Python multiple choice problems each have like 40, and then string 2 and list 2 and coding bat. And yeah, that's all the homework. I don't really want to take too much off your time because we're already past a bit. So yeah, if nobody has any more questions, I think we'll end for today. Bye.